Welcome to the world of assassination. As Agent 47, you get to plan and execute the creative demise of some unfortunate NPC by simulating realistic behavior, dynamic environments, and adaptive systems. The AI contributes truly to the immersive and engaging experience in Hitman. In this series, we are going to explore how the AI in Hitman is designed to create this complex and reactive world that challenges the player to think creatively and strategically. Agent 47, defined by his barcode tattoo and unmatched precision, is the result of a rogue scientist named Dr. Ort Meyer, who did a series of genetic experiments to engineer the perfect assassin. After breaking free from his creator, Agent 47 found himself recruited by the ICA that offered him a new purpose: professional assassin. Throughout the series, themes of identity, morality, and the quest for freedom are prevalent. As Agent 47's character evolves, he grapples with his purpose and the consequences of his actions. The narrative is rich with intrigue, betrayal, and a deep exploration of Agent 47's complex nature. The foundation for the AI in a world of assassination was already laid back in Hitman Absolution. NPCs follow a daily routine and schedule, providing a living and breathing world. They go about tasks such as cooking, cleaning, or patrolling, adding realism to each level. Conversations, reactions to events, and interactions with objects add depth to the gameplay. NPCs have varying levels of awareness and suspicion based on their respective roles. Guards and security personnel are more vigilant compared to civilians. NPCs react to unusual sounds and behavior, such as running, carrying weapons, or being in restricted areas. While all NPCs have a behavior tree, controller, and sensor, not all NPCs are equal. Crowd of civilian NPCs would mostly play an anim montage and only become active when reacting to player behavior. In Hitman, an influence map is used to help the NPCs understand the environment and have spatial memory. The influence map in Hitman is created by creating a uniform grid using the nav mesh. An influence map is also known as a heat map. So how do you create this influence map from the nav mesh? Start by creating a game instance subsystem C++ class. Create a map layer enum. Spatial memory is in the form of layers, which is then combined to give the current worldview of the world. Create a map node class of type object. Add a 2D vector property named node location to store the node location in the grid. Add a vector property to store the node location in the world. Finally, add a float property to store the node's value. Create an influence map class of type object. Add a vector property to store the size of the map. Add a float property to store the radius of each node. Add an array of map node property. Add a map layer property. Add a vector property to store the world location of the map. Create a actor influence class of type object. This object will represent each actor that has influence in the world. Add an actor property to store the actor. Add a map layer property to indicate type of influence. In the subsystem class, add a public float named global node radius and set the value. This value will determine the size of each cell in the uniform grid. Add a influence map property named world map. The result of combining all the layers will be stored in this property. Create a init world map function. This function will create a uniform grid from the nav mesh and set the world map property. Create a function named create layers. As the name implies, this creates all the layers. Create a function named generate map. Again, as the name implies, this will generate the map. Add functions, register influence, and update influence. These functions manage actor influence. Add a public function named debug draw map. As the name implies, this function will draw the debug view of the map. Add a public function named find player world proximity. This function will update the player layer with the current location of the player. Add a public function named reset map. This function clears all the values of a map. Add a protected property of type fTimer handle. In order to reserve system resources, updates will be done via a timer. Add a tmap property of types map layer and influence map, named map layers. This will store all the layers. Add a protected property named registered influence, which is an array of actor influence. Add a function named find player influence. Add a protected function named refresh world map timer elapsed. In the level blueprint, execute the initial world map function on the subsystem. Next is registering the actors with the influence map. To do this, we are going to create an actor component that will interface with the influence subsystem. Add a public map layer property. Add a protected actor influence property. Add a protected function named register influence. This method will register the owner with the influence subsystem. Add the component to the player character and set the influence layer to player. Now hit play and the result should like this. In the next video, we will explore how influence maps are used in Hitman. Do you find this helpful? Share your thoughts in the comments. Thank you for watching. See you in the next one.